Test, test. Oh, that's better. That's a lot better. Hey, look, we've got full screen now. Ah, the joys of late nights working on systems. Talking about systems, programming games. We're going to be programming games. Yay! At long last. This is it. And I've decided to stop looking at different systems now and do some programming. How about that? Isn't that nice? So we're going to be programming games and it's going to be fun. Sit back, relax. There's no rush. No short videos. Nothing like that. It's all going to be recorded and we're going to be placing it all upon YouTube so you can catch up whenever you want. And yeah, I'm going to have some fun with this. I'm going to have a lot of fun with this. So let's kick off. Games. What makes a game fun? What makes a game? Well, a player. And that's where we're going to start. We're going to start with a player. Let's see what we can do with that. If we can make something fun, we'll have a game. Pretty simple stuff, really. So, oh, hello, viewer. Welcome. Appreciated. My name's Blades, and yeah, we're free to finally do what I want. Yay. Log in. Okay. I've just logged in. It's Twitch. I've been told now. Twice. Interesting. So we're now running OBS. So this should be a very, very sweet, nice, clean video or stream without too many problems. I'm hoping. Onwards. What will we be programming on? What's operating system? Whatever you choose, it's not up to me really. This is about the people, not me. Let's pop over to Linux and start there. Here we go. And see if I've got a keyboard and mouse hidden around here somewhere. Alright, found a mouse. This keyboard's all there. Yay. There we go, all there. And we'll need a project space. Let's see what project spaces we've got. Okay. I got a feeling there's other stuff in here. Yeah. Done. Right, we've got a project space. That's going to be useful. What we're going to use to program on, I'm going to use Qt. We'll use Qt Creator. Alrighty. We'll clone. Okay. I'll rename this to Rana. No. Why does it keep doing that? I'm not asking it to, just want to rename it. And the keyboard shuts down. Back. Alright. So let's start with new. Choose. Alright, we're going to put stuff in here, aren't we? Yeah. We'll use that as default project. What should we call the project? Well, in the usual style of everything else, we'll just call it Sandbox, I guess. So, Sandbox it is. Alright, everything's ticked there. QMake, yeah, go, go, go. QMain window, I don't like that name. What should we call it? Let's call the class application. Window. GCC 64-bit. Sounds good. Alright. Looking okay. Looks fine. I'm going to create a second project for this. Just thinking, is it better to write in one project or start second? No, we'll start with one project. I think we'll keep it simple. We'll expand it later. Yeah. So we have a project. It looks something along the lines of this. So that's our application window. Let's see what we can do with this. It's 800 by 600, that's fine. Fixed. Fixed. Select. Yeah, that's okay. Let's not. Window file path. Sounds okay. I'll have a push button and go to slot, clicked, cancel. Right. This will be our exit button. Yeah, that's fine. Fine. I'm not honestly bothered about this. I'm going to leave that for a second. How's this look? Looks okay. Yep, that looks okay. Missing something. Okay. Alright, let's just think about this screen a little bit more. Let's see what we've got. Geometry, size. Minimum size. Doesn't come under size. Okay. Everything looks okay to me, really. We'll call it sandbox, I think. Don't have any window icons yet, we'll have to fix that. No. Okay. I think I'm alright with that. Let's see what we have on the left hand side here. Buttons, item views. Containers. Oh, input witchy. Ooh. Mm-hmm. Text browser. Interesting. List tree table. Not sure which one I want to use yet. Item view model based. Item based. Hmm. Dooby-dooby-dum-dum. I think it's one of these. I don't really want a table. Well, do this button. Double click on it. Call it exit. Right click it. Go to slot. Clicked. Okay. Clicked. Do this. And just close it. I'll take care of everything that we need. What kind of views can we have? I'm looking for something like a text view. Just a simple text view would be nice. Q plain text edit. What widget is that? Let's not. code editor. Okay. No idea where you just put that. Good. Okay. Text. Align edit. Text edit. Plain text edit. It's a widget. Q plain text edit. Okay, so I know what I'm using now. Okay, that works. All right, I'm just going to leave it like that for a second. See what we can do with Q plain text edit. Let's start at that. Yeah. We'll call it something. We'll call this output. Not sure, it could be input as well. No. I will need something like an input, I think. I think that's going to be it. I can't think of anything else I want right now. Well, you can see what's going on here, can't you? I think. Yeah, that looks okay. I haven't exactly used the screen very well, but let's just try that. As I have. Looks okay. Yep, that looks okay. At the moment, no idea how it's going to react to anything. So there we go. Where shall we start with our game programming? thrown together a very, very simple UI. Let's start by making a scene. For the player, we need to put the player in a scene. Alright, let's think about this a little bit more carefully. So one thing you want to do when you are designing a game is think carefully about what you want to do. I'll pop you there and we'll get the player going. So let's have a player. Now the player is going to be the central focus of the game. You have to make the player invested in the game, want to play the game, rewarded, some kind of advancement, you know, everything that makes a player happy. To generate a player, I think we're going to use an ECS. Which is an entity component system, as I believe that that is possibly the most versatile system to start off with and the simplest. Ooh, hey! What is the pattern mode of the LEDs on the keyboard in this video? None, I don't think. Interesting. Interesting question. I'm not sure quite how to answer that, shall we say. To make an ECS system is very easy. So I think that's where we probably will start. We already have a UI system. So we've got a GUI. And for that I'm going to use Qt. What would more interest you is what is the pattern of LEDs on my main system? And why is one of them yellow when it shouldn't be? That's interesting. It's using my graphics card to do the broadcasting. Got you. That's why. They show the heat of the components on my computer. All of my LEDs go from green to red. We've got one just bordering on yellow now, which is the graphics card. So I can instantly look at my computer and say, oh, that's heating up nicely. As for my keyboard, I am using the cheapest piece of junk I could find. That reminds me, I need to buy a real keyboard, don't I? This is a gaming keyboard, it doesn't have half the keys, which makes programming interesting. put it that way. So the central focus, ECS, GUI Qt. Lovely. So we need to come up with a good way to do an ECS. Are there any bad ways of doing it? I'm not sure. I've done ECSs before, and recently, haven't I? And we'll go with event. I think that's what I was using. That didn't work too well. Hmm. I must. Let's try that. Why is this so hard to find? Interestingly hard to find. I can't even remember what I called it then. Well, that's helpful, isn't it? Maybe it'll come back to me. Maybe not. Right, sandbox. Add new. I will have a class. Class name. We'll call it scene. And I don't want it there. We shall put this in source. I'm happy with that. There we go. We've now got a scene in source ECS. I think we can deal with this. How's this looking? Interesting, but it'll do. Yeah, that'll do. And that's the basic setup. I think we can do it from there. Other things I might need. Well, other things I want, shall I say. I think we could do with a couple of header files just in case. Usually a good idea. I'm not sure whether I want an entity file or not. Right, I'm not sure. We'll prepare a couple of side files for not necessarily controlling this, but we can have a couple of definitions going, I think. Let's keep it as simple as possible, and we'll just have an ECS header. At this point, I want to develop a game, not just write one off the top of my head. This could turn out to be different. We can type def component. Or just struct them. Now, something we do need to do is namespace this. I just realised. If we don't namespace it now, it just becomes murder later on. Now, the sandbox itself is never going to grow too much. It'll probably just be the top files. Anything that goes into the sources is being developed probably for a library. Choose a library name. Already got one. To be disclosed at a later date, I guess. But we are going to namespace this. There's no way. There's no way I'm not. Okay. I just don't want any conflicts with any other classes within Qt. That's usually bad. Oh, welcome to people joining us, and hello there, Polyglot. Good to see you, matey. I am just designing a new project. The new project currently, I suppose, is player. What we have in the new project is not a lot. I've literally just created it. So to bring you up to speed, we have ooh, don't do that. So we're going to be programming games, obviously. This is a games club. We're going to have a player who's going to be the central focus. We're just starting to do an ECS. We're going to use a Qt for a GUI. That's all we've got. This is our game. And that's where we're going to start. It's going to become more interesting as we develop, but we'll see where it takes us. And yes, I've got my full screen back. I had a nightmare with that the other day. Alright. So we'll just run into this. Namespace, what am I going to call it? I'm going to call it night. With a capital N. That's when I do most of my work at night. Alright, let's get some spacing going on. Let's start tidying all of this up and making it look as though I did it, not the computer. What are you up to, Polyglot? Out and out. That looks better. Now, of course, another thing that I'm going to say now is if people do want this code, I'm now freelance. I'm no longer working. Do I give it away freely? Interesting ideas. To understand that, I am no longer being paid for being on Twitch. Okay. So some kind of structure going on here. Build and run. We're okay. Lovely. We have the start of a program. Well, a sandbox, anyway. We have a start point. And one of the things I do know I need is going to be a header file in here. Add new header file. In sources ECS, and it's just going to be called ecs.h. We will have a namespace part to this, just in case we need it. But mostly, I'm looking at hash define. If I could spell it. Oh, this series is for you people, not for me. So if there's anything you want to know about game design or how to go about things, then ask and we will research, because that's what I do. I'm not a programmer. It's an ECS, so we're going to have max. Can I put that within the namespace? I think I can. No, don't do that. I've just realised that's a very bad idea. Hash define. Better idea. Name it. Why have I done that? Because I don't want more than 32 entities at this point in time. As you will see later on, we will be able to... How can you put it? Create entities. But the entities list will be pure entities, whereas what we have in the game will be instances of those entities, or copies, or whatever you want to call them. Alright, and I've just said entities again, and I've just realised we're going to need something else. But that comes in afterwards, I guess. Let's get the entities going first. We can. With entities comes components. Can't see any reason to make anything more than a header. So we'll do that. Just that's that done. Again, namespace. No. Lovely. So that's going to be our component. We can actually enter our first component in here, which isn't a component. It's going to be use an enum class, I suppose. And we'll call it components. And we're going to have one component at the moment. and it's going to be called comp total. Big enum class. Enumerations. Let's talk about those. How they work is an enumeration is basically something, any word, really, and that word will be enumerated or set to a number, an integer from 0 to whatever. The first item equals 0. So we have 0 components. So it makes sense when you say it that way. We could make a component. Alright, we'll make a component. Something to test anyway. So we'll have component position. All you do is put a comma. Component position becomes 0. Component total now equals 1. Very simple systematic way of introducing a component table. Now, if you do that, then we'll just use a struct. And we will call it position. In the struct, what is a component? It's data. So we shall have int float float. That's bad. I just realised what I've done now. Alright, okay. X float Y. That's it. That's your data. We're going to have an X position and a Y position. Okay. So we've got components. We need to include ECS.h. Scene has to include ECS.h. ECS.h, on the other hand, and this is why we're doing it, includes everything else. The code model could not parse an include file. Oh, of course it can't. Because it's not that, is it? Yes, it is. Go details. Main file cannot be included recursively when building a preamble. Oh, come on. You're joking me. Have they fixed this? No, they haven't. I don't think they have anyway. It's a way of cheating. What I've done is I've looped them, looped the headers. And I've done it on purpose, obviously. They include themselves. But if you do it behind that, it should work. Okay. Let's type this in slightly different then. Alright, I've also got something weird going on here. So yeah, I've made a mistake. I've got source, ECS, scene. Right, okay. And yet here, I've got this thing. Alright. Alright, you too. I'm going to put them in full. See if we can break the system. I can't break it. No, why can't I? Totally illegal to do this. Hey ho. Doesn't seem happy. Actually, I just realised I don't even want it there, do I? Oh god. Hash include. Source. ECS. ECS. I'm not coming up with errors. Now I'm worried. Let's see if it'll give us anything. So it's night. Scene. And we'll call it m_scene. I'm not sure where I want it, so we'll just leave it there for now. No. We'll do that. We'll make it a raw pointer. We'll come back to that. Comma m_scene equals a scene. Like that. We now have a scene we can work with. Sounds good. I don't want to look at the errors. Not for now. So let's compile that. No errors. It runs. There's no memory leak, but I'm going to fix it anyway, don't worry. You get done first, you get done second. So do in reverse. There we go. Done. Right, that's now proper code. Fantastic. At this point, I'm not sure whether I want to save that out. But I will. Complete setup for East develop. Okay. Done. And that's basically it. We now have a scene. What can we do with this scene? Not a lot. We can do absolutely, well, nothing. What would we like to do? Our scene. How's about, how's about we make our first function? Yeah. What we would like to do is the first action. So how do we do this? We put in void. Add entity. Now, really, that should return us something. How's about an int? Because that sounds fine. Can't have an entity that's -1, so we'll return that. This begs the question, how are we going to store entities? Well, an entity is not going to be part of scene. Oh, I don't know. We can make it part of scene, can't we? I'm going to do something a bit weird. I can't see why not. We'll just pile it in here, can't we? So we'll do a struct. We'll call it entity. Yeah, it's inside a class, don't worry. And inside of this, we are going to have one item, one piece of information. It's going to be static. It's going to be entity. And it's going to be no max entities. Do we need to do anything else? Yeah, we'll have to give it a type. So we'll have ints, because why not? Entity has the same name as its class. Okay, fixed. No, do it the other way around. Okay. So there's our 32 entities. But I said we can have instances of them. Register. Entity. At this point, taking entities, can't we? Something like that, I guess. Alright, okay, that gives us an idea that we can add entities and we can now register an entity for the scene. What's the difference? Well, entities, as I said, they're lumps of data amassed together to form an entity called components. Well, an entity is a number, 1, 0, 1, 2, 3, 4. Well, an entity is just a number, it's an ID, identification number. The registry will register any entity into this lot. What should we use? We got a Q vector. Is that doing what I think it's doing? Or is it doing something different? I think it's doing what it's doing. So we can have a Q vector or registry. What will we register? An int. Something like that. Oh, that wasn't bad. Let's take the Y out of there. Does that look better? Yeah, that looks better. We're also going to need a static. So we're going to need a static int. Static. There's a big reason for it. M underscore entity ID. I'll do. That has to equal something. Non-const static data member must be initialized out of line. Okay. Do we make it a const? Can't. Entity. ID. 0. I'm not allowed to do that either. Okay. Just wondering whether to take this outside. This is the important one. It's got to be static. Kind of pop it in here. Every time we come through here, it won't be reinitialized. Will that be okay? Probably. I think we might have some success with that. Not sure. Worth a try. Ah, run out of coffee already. Isn't that nice? So we've now got an entity, an ID. Right. Now we've got a registry with ints. Good. We need a star components. We need a pointer to the components it owns. We don't know how many components it owns. That's irrelevant. Oh, this is the awkward bit, isn't it? How do I wish to do it? Trying to think of the pointer system within this language and see if it's valid in different types of ways. We could push back into a vector. That's not a good idea. We know how many entities we've got. We know how many components we've got. All we have to do is cross-reference them. So it's night components, component total. Okay, what's wrong with that? Is not implicit. What? Wanted an unsigned long. Well, I didn't know that. But what is it? Hmm. That tells me what components. That's the reg. I don't like that. An entity shouldn't have that in it. Mm. Type. We did. Hmm. That's weird. We have to add components. How would we like to add components? This is the trick to a good ECS versus a bad ECS. First of all, your entities must be a number. When you make an entity, you need a way of storing the entity, an int, with its component. This is where I'm thinking that type defing might come into place. Music won't change once it's set. Static won't change. I need a void. I don't know what components are going to be added. Not happy with this idea. We could just call this. It's not going to give me a star void, is it? Which is interesting. Not going to allow me to do that kind of thing. Inherits queue list. Type name T. Type name. I'll do it that way around. Okay. If I can do it that way round. Yeah, there's a template involved, isn't there? Must be a type. Don't like that. What I would prefer here is that thing, night max entities. Component. Why is it only coming up with scene now? That's weird. Oh. Yeah. I get you. Let's not mess with that then. This just becomes a void star. That's not M registry though. What I would like in brackets. No, we can't do that either. What we can do is enter. And then it would be a Q vector. Ooh, didn't like that. Too many template arguments for alias template Q vector. Okay. So this would have to go in there. It's a naming convention. I don't know if I want that. When we push back into the registry, what are we pushing back? We are pushing back an entity with its component. So that's not correct. We need a type def struct, okay. What we're going to call it? Object. Let's try object. This will have an int entity ID and a Q vector void star of components. We can then take you in here. Yeah, I think I prefer that. What do you think, Pete? What do you think? Would that work? We took an object, gave it an entity ID, and then gave it some components, threw it into a registry. We could then access every object. Now there's a piece of C programming for you. Would that compile? No. So when we want to register an entity, no, that works. I'm just trying to cover all the possibilities that you can have for an entity within one very, very short setup. And I think that covers all possibilities because you've got the entity ID which tags into your 32 entities. You can have as many objects as you want, or instances. Is that a better word? No. So each entity needs to have an object associated with it. That part I need to think on, just for a minute or two. I think we've got to the stage where we've got an entity system, an ECS. We need an initializer. That's 100%. It is now that I've done that. And I've used ints, haven't I? A plan is forming. Right. Okay. A plan is forming. I'll make a cup of coffee. Yay, I've got coffee. What is an entity component system? This is the biggie. This is the real biggie. So, we have an entity. We have its components. And systems that work on components. So the components list, so we have this entity, which is literally ID. And then we have a list of components. One of which is going to be position. We don't know how many components it's going to have, but we need to know that it's got position. And then, of course, we have the systems. Which operate on the data. We could really do with component list to make it efficient. Otherwise, we have to go through every single entity and every single component to find out which components it's got. That's inefficient. What we can do is just make a table. A component table. And we can do that. We can break the rules. Shall we break the rules? No. We shall not. All right. So we now have that. We do have that. That just develops itself as we go along. So this table, how do we want to introduce a table as component? Good question. We can break the rules and put it here in entity. So we could have a table here has component. That wouldn't be too bad. Make it static. All right. I'm going to break the rules a little touch here. I'm putting here static bool. Ah, no, it's an int. You're about to find out. Has this is where that thing comes in, which I wanted before, which is component from total. That's where that comes in. Doesn't like this because it needs to be an unsigned long. It's fine by me. And if we go over to ecs.h, we can now do a hash define. So that's to start with night, and we're just going to call it unused. And it's going to be -1. Okay. What happened to my initialize? Whilst was away. I think we are going to use that. Oh, it reverted, did it? Okay. That's fine, we'll sort you out in a minute. We need to initialize this though. If we don't, it all falls to pieces. So, for int index equals 0, whilst index is less than night max entities. Index all right. Entity doesn't need to be new, does it? Yeah, I think it does. That way round then. Alright, so we want this in which order? Order matters. So I'll pop you here. At this point, we'd have something. So we have M entity, which is going to be made equal to a new default constructor will take care of that. And M registry will equal new Q vector for object star. Like that. Looking more like it. Does mean we need to delete them. Do that. I'll do it properly. Idle. We're actually getting somewhere now. Okay. Happy with that? So obviously we can't destroy the entity without destroying that, so we have to do it in reverse order. So 4. Oh, wait a minute. Doesn't a QVect have a delete? It's got a clear. Erase. Press F1. What does erase do? You know what I think it does? Clear. What does clear do? The void. Okay. Removes all the elements from the list. Thank you. That's clear then. Good. Makes that easier. And then we can just delete. Nice. Now we can go on to delete the entity. Now I've made the entity more complex than I should have done for this. It's got components now. That's okay, that's okay. Entity dies, they'll die. The static, perfect. Nicely set up. And that means we can just delete it. Okay. Fantastic. So we can construct and delete. Now we need to initialize. And we need to initialize the entity. So m underscore entity. Eek, did I really do that? No, it's entities. Go for that. And that's index. And that's going to equal a night used. That will take care of part 1. And for int zero, as long as comps less than night component total semicolon comp plus plus then we're just going to do m entity we're going to take that as component Bumps. I was using integers. Right, so that will initialize the entities to unused. We don't need to initialize the registry because the registry is basically null pointer at this point. Empty. Right, so we can initialize the scene. Done. Can we add an entity? Yes, we can. How shall we do that? We would take our entities, underscore. We would set our entities index which in this case would be entity ID, we can then add one to the entity ID. No, we can't. And that would just become the entity ID. So it isn't set to -1 anymore, means it's now in use. We would then need to add base component. Really matter what it is. LA void. Split base components. That will take in int entity ID. And it's private because it's not to be accessed from outside. This is an internal. You have to go through add entity. Save, refactor, go. And here we can add a component. So m underscore entity has component we didn't set up the house the night component position. Again, doesn't like it. What do you want? An int. And that's going to be equal to 1, I think. We then have to add that component. Oh, yeah. Oh, bugger. Made a mistake. As component needs an entity ID. It needs that. Didn't spot it there, did I? That would be index. That's correct. Thank you. So we can now tell it that it's got a component. How do we get that to work? We have to create an object. Hmm. Yeah. So here we would have object, object. I haven't dealt with this lot yet, have I? Object. We haven't set. Doesn't matter, it's new. So what have we got? We've got object. Do it properly. Object. Entity ID equal. Leave it. Entity ID. Object. Components. Dot. Components. A vector of component. Avoid stuff. I didn't start that, did I? The externals. Yeah, that's correct. The object is a point in memory. This is within the object. Means I can now do that. And I want to push back of new position. Actually, make that first. Position component. Position. Equal. And X. Did I put float or not? Don't need to do this, but no, stuff it. We're not doing that. Component, get your act together. Do it for me. Thank you. That'll give it a default. No. So we now have a new object. Where do we store the object? We can't really, can we? We can. Because we broke the rules. So in our entity, we can actually keep the staticness. We need to keep the staticness as much as possible. Now we've got a problem with object. Can't do that. Now I can. Ah, for God's sake. What's wrong with this? O, B, J. And you can set that one. Don't need to. Non-const static data member must be initialized out of line. Okay. That has to go into the initializer. I meant object. Null pointer. Done. Create the object. Pop it into the entity. Bob's a good one. Ah, done it again, Anna. We need an ID on it. This is the problem. Oh no, object. Don't think we need this. We can just push it back into the registry. Yes, we don't need it. Overthinking. Just push it back into the registry. Where it belongs. Don't need that. Nice idea. Ain't gonna work. Alright, I'll think about that in a sec. Actually, don't know. I think I like. Oh, right, it's this one that's gone out of line. Okay. Space now. Does seem to be working out. We didn't clear it. Doesn't matter. And all we need to do is push it back. Done. Yeah, it's got an ID. As long as we've got the IDs matching up, we're fine. This is what I was thinking about when I started putting that object in. At this stage, I'm not overly keen on that. We put it in, but I'm not overly keen on it. So, that's what we have. We can initialize and add an entity. We have base components, which give a position to our entity. And we get the int back. Right, let's try that out. Let's try some test code. That's what we get. I'm just going to put up an IO stream. What can we do with entity 1 now? It's just a number. So, nothing. Can't do anything with this. Just a number. So if we want any information about this entity, we have to ask for it. So what we would probably do here is something like, oh, this is going to look. We need to be able to access a component. Or access the entities component. We would need a reference to whatever has been stored in. We need the memory location, basically, in the registry. So we need to be able to interrogate the. We haven't also put entity. We'll do that after. Okay. Night component has not been. Is where this circular thing comes in, isn't it? That's I'm going to. Round. This is a problem with dependencies when you're trying to. Dear. Ah. What's that? Oops. Alright, simplify it down and. Oh, God. You're okay, and you're doing in component. You're absolutely. Knight does not name a type. Pardon? Have I forgotten how to program all? The class, it's not supposed to be a type. What are you on about? No type named scene in namespaces. Don't want a type. Dumbos. Ah. Does now. Well, that was better. So we get a warning. And then some of my C programming has upset it. Undefined reference to night, scene, entity, entities. Line 24. Yeah. Got things in the... Undefined reference. Okay, M entities. Did we knew it? Did. On line 8. Hmm. I did gloss over a few things there. Oh. There's no constructor. Yeah. Our ECS works. By putting static there, the compiler can't find anything to construct, because these variables are held as, well, in a V table in the background. There's pointers into just a block of memory. No way to instantiate them. You have to instantiate them direct, which I could do. I could keep this static. But all that does really is complicate things, so why bother? If I'm in C, then yeah, you'd be static, because you'd want it that way. The problem in C++ is, who does it belong to? Now, as you've seen, I've kept everything within scene on purpose for localizing whether things are going to work or not. So I want entity 2, but I want the entity right. I want to find out whether that int increases, which it doesn't at the moment. There's also another problem. We're going to run out of entities. Let's add the increment. That's obvious. But I want you to see how this static variable works. Yes, it's supposed to be reset to 0 every time you come in to add entity, but it won't because it's static. It will only ever be initialized once. The first time it comes in to add entity. That's the memory map. That could work. Could work. Let's find out. I'll deal with that running in a the out. NT ID what we're going to put here, entity 1. Uh, 2. And just put entity 2. What do we think? Entity 1 ID 1 to ID 2. Now, what happens if we delete entity 1? And now you can start with, we're starting to get a system here where we can have entities, or at least entity IDs. Whether those entities exist or not, we don't know yet. Not for certain. We theoretically think they do. What would happen if I was to place in entity 1, then do something with entity 1? Somebody comes along, shoots entity 1, and entity 2 is then appears. How can we delete entity 1? What process for deletion? Why did that do that? Right, so we have our first proof, or proofing, that we are getting identification numbers back from scene add entity. And we are getting correct things back. So we're going to check through that as well. We seem to have sorted out any issues. Yeah, all of these issues seem to have gone. We've messed around with the includes. Alright, I think at that point, I'm okay. Okay. First test for creation entity, because that's all we've done. We haven't tested the fact that an entity exists or not. All we've done is we tested the IDs. Oh. That's been a success. I'm pretty pleased with that. Okay. No, that's the wrong mouse button. Oh, my live stream's back to excellent. My bitrate's back. Everything's back. Hello, we've got new people joining us. We are in a programming games club. We are looking at possibly starting a game. And we're just looking at creating the first part of our game. So, welcome. That's the first thing. The player's going to be the central focus. We're going to use an ECS. We're going to use Qt as the GUI. Currently programming on Linux. AC. We can swap to Windows at any time because we're using Qt. We just transfer the files over. The entity ID is now tested. That's all we've tested. So I'm actually happy that that works. We don't know if it's got the position component, though we've given it one. We don't know if it's got a component, a has component table, but we've given it one. So that's what we're going to be trying to address next. You see, one baby step at a time, with a bit of luck. Oh God, I didn't want that to happen. Go back. I hate using middle mouse buttons. I've got plenty of. So we're working through bit by bit. So shall we find out if we can get hold of something from here? Now, I remember back to looking at QVector on the manual, and it said it inherits QList. What does that mean exactly? It means we might be able to use something like QList. That could be interesting. Have I got any coffee left? Have I earned a coffee, people? You think? I mean, I'm not after viewers, I'm not after money, I'm just after having fun programming. So I think I've earned a cup of coffee. What time are we on? God, it's 2 o'clock. How long have we been going? 3 hours. And we've got beginnings of an entity system. Okay. That didn't go well. Oops, that didn't go well either. Escape out of that. Okay. Sorry, I've got multiple keyboards here and they're not exactly. Easy. Whee! Okay, sorry, Poppy. We have to move now because I'm doing this in a more relaxed style these days, as I'm not getting paid for it anymore. Be right back. Now this is going to be a shocker. And can we get rid of this on screen now? Oh, we can. Oh, that's ace. Whee! I do like this. It's fun. I could play with this all day. No, we can't. Let's do something properly. Now, because we've set up this system in a spectacularly strange way, as in simple, it should be simple for us. Just to, well, remove an entity. Yeah, remove an entity. I think that's what we're going to call it. How should we have a look at that then? Let's have a look at how we added an entity. So we add an entity, the entity's ID goes up, and we just return entity, sorry. We didn't add any components at that point. Possibly not a good idea, but shall we now try adding them? No. I want to be able to delete an entity. Here comes the thing. You can't. Or you shouldn't. You see, the entity belongs to the scene. And we have max entities, so we can have a maximum of 32 entities per scene currently. Obviously, that's a very low number. And it's probably going to be 1024 very quickly. But the reason it's 32 is because I'm not going to be doing that much on graphics yet. When it does come to graphics, doing graphics can be a bit tricky if you want to do 1,000 3D models. Not happening. Not right now, anyway. Starting small. Do we want to be able to delete an entity from the scene? Well, the answer is no, because as I've already tried to imply, that's not really the idea. The idea is on the object. We can add and delete objects. Well, the objects get added automatically, but we can delete them. So it's the objects that I'm interested in if you want to remove an entity. So now we have to define or make some kind of definitions for ourselves. What are we actually going to be dealing with? What is that int? Is that int an ID number? Yes, it is. It's the identity number for an entity. So we can add an entity, but now we need to add that entity as an object to the scene. And that's what we call registering. So we do need to register. And it is just going to be entity ID, isn't it? We are registering here, or automatically. So the base entity actually gets registered. That's fine, because we're not going to be changing the base entities. This identity is never really supposed to be used by the programmer, are they? No, it's not. We're going to keep it, because we're going to need to add entities to test the system. So when it comes to deleting an entity, we're not actually wanting to delete the entities themselves. What we're really looking to do is this registry. So if we did delete an entity, we would need to delete it from the entities list and from the registry. Okay. That might not be a good idea. Because then you would lose all of your components. This is where I'm thinking, do we need to register? Do we want a base registry in here? We're bloody broken rules. Made it more complicated than it needs to. No. And that's possibly why I started removing that thing there. So we can add objects. What we really want to now look at is this registry. So let's have a QVector object reference. A QVector object star reference. I'm going to call this view registry. I'm just going to keep it blank there for now. What this is going to do is return a copy of the whole registry, which is not what we really want to do. We'll get to that later on. Definition. I forgot to save. Okay. So here we just return registry. But it's a pointer. Now, I'm thinking, hold on a minute. That. I am really thinking that I don't want people messing around with the registry whilst it's in their hands. Sorry guys, but it's not that I don't trust you. I don't trust me. So to stop myself from making any big mistakes, I'm going to do that. I'm just going to make it a const. We haven't added anything to our registry. We've got base components here. So let's do that. Base components. And entity ID. There we go. Entity ID increments, and we carry. Already shown that that static int entity ID is working for what we want it to do. One of the things that we could do here is a safety check. This is going to be an interesting thing to do. And I don't like doing it. No, I'm not doing any safety checks. It's up to me to get it right at this point. Not for me to programming safety checks for myself. So base components, that would then run this function at the bottom. And the last part of that is mregistry push back an object. That object should have component called position. Now remember I made it a void star, which is why this is about to get very, very, very... Back in application window, we can now ask for that. I think we might need QVector though. Auto 3 equals m so we now get this registry. And it tells us what it is. It's a unused QList night scene object star. Notice it says QList again. So it's returned to us a list of objects or pointers to objects. Let's see what we can do with that registry. So for each object, which will be a night, no it isn't. For each mscene get get. So it's night, this is going to be colon. Scene colon. There's the object. One column object stuff. I don't think we can it is a private member of NightSync. Put those Okay, let's let it be. It's type def. You can actually put this into the header, I think. But I don't think we're using the header right. Okay. Object in registry. What can we do with that? Well, we could take the object. It's a star, isn't it? Got a void star components or list of. For loop today. 4. I'm not doing this in any specific way. I'm work at this point in time is less than object components dot size. So we're now looking at a single object with an ID in the registry. So let's start formatting. So we can put out std out just as a complete test. Object ID that's going to be object entity ID. I'll do that for now. So I've got an object ID being typed out. Take care, polyglot. Object component size means we're going to go through step through each component. What do we want? I don't want to do anything silly, and I don't want any. Let's get this working first. Interesting. Now we can see our first mistake. We're actually returning the wrong entity number. You see, object IDs are 0 and 1, and we're returning 1 and 2. So we've already made a mistake. We can alter that. Right. That again. Now we get 0 and 1, 0 and 1. Our IDs now match up. We do now know that we're getting objects because we've got ID. Are entities and objects the same? No. Entity is a blueprint. An object is just use for whatever you want to use it for. A bunch of data. Graphics, sound, whatever. So we've managed to get that far. We've now got this working better. That's never a bad idea, is it? And we know we've got our component, and we know we've only got position. Okay. Well, let's look at that position component. I don't really want to do it that way. Got one component. It gives you an idea of what can be done. Oh God, what did I just do badly there? Wasn't what. So we know we've got the object ID. So let's try something like this. X. What's that going to be? It's going to be object component one. You have to do a search, wouldn't you? You'd have to get. We have to do a search on that object. Can't just do that because we don't know what that is. I do know what that is, but that's not the. I don't think. No. See, there's nothing happening here because it doesn't know what it is either. It's a void star. It doesn't mean anything. Just a component. It's a pointer to a memory location. haven't told it what that memory. If I was to cast this to a knight, position components, no matching conversion for C style. Well, of course there is. So what we would need is a pointer. That's a pointer. Components. Go from void. Still no matching conversion. Now you're not right. Thank you. Yeah. That's what we've got. And it says we can do it. Well, position X is correct. We can check this by just putting in a little test. What we would do is we would probably put it just a test variable. Do something with it. We'll make it an no, float. Doing okay. So when we make this new position here, what we can do is we can test it. So we could say position X plus equals variable. Like that. So what are we expecting from that? We've got a plus plus, so it's going to be 2 and then 3. Position X, that should be 2 and then 3. Let's... And there you go, X is 2. This is working. But as you can see, it's rather easy to do it here. Get rid of it. Don't leave your test. It's quite easy to do it here, but when we were looking at it back in our main, it wasn't. Now, this is where something interesting can happen, because you've got design choices to make. And my design choice is to say, well, not my problem. Is that an acceptable line of code? Yes. The thing is, if you didn't want to put that line of code in, you would then need to make a getter. And you would need to get the position component. And if you make a new component, you then have to get that component. Then when you make a new component, you'd have to go and get that component. Each one of those is a function. And you keep getting and getting, and you just get a massive list of get. So to save myself 1,000 lines of code of getters, I'm going to say that that is an acceptable piece of code. It's not, but I'm going to say it is. Is there a better way of doing it? There must be a better way of doing it. Do you know a better way of doing it? Hey, tell me. That's what this is. It's a game club. And if you don't tell me, I'll find one. Ha! Suck on those eggs. God knows. I don't know. If I think of one, I'll do it. If I don't think of one, I won't. That's the whole point of game design. Now, so far, we haven't spoken about this ownership thing. And this is the crux of a big problem that's just occurred a few months ago. Now, Google went off and in their infinite wisdom made an MMO called New World. Big hype. Next-gen AAA game, which had a problem. Ownership. Each one of these things that we are now looking at is an asset. It's a game asset. And each game asset can be owned by a player, an item, an object. That's why I just called it object, because I didn't know what to call it, because it covers literally anything. If you can think of a good name for it, please tell me, because I would like to change the name from object. I don't like that. I've just been very, very lazy in my naming conventions. I'll try and think of something better. We now have an ECS system, by the way. Full ECS system. You can access the components. You can set the component. Which means you can use any system on those components. It's complete. But what about this hanging question? What happened in New World? People found they could duplicate items. They found that the system, the underlying system, when trading occurred between players, the item was duplicated. A new item was given to the person who was being given the item, and the person who held the item had their item destroyed. Well, if you accidentally disconnect during a trade, the person whose item was supposed to be destroyed wasn't. You can't do that. You have to transfer the item. Now you're saying, oh, well, that's dead easy. They've all got an object ID. But I've already said that they're going to be instanced. So everything's duplicated. And this is where we come on to the biggest subject that we have to place into our ECS. This is the biggie, folks. Now this is going to be interesting because we're in Qt as well. I haven't a clue how to do this in Qt. We're about to find out. Maybe today, maybe tomorrow. But we're going to find out. Our ECS system is actually complete, and all we have is identity and a base component being added. A registry which we can view. That's it. It's not a true entity system. I did cheat. But we do have objects being created out of our entity and being added into a registry which can be accessed by the scene. We have everything we need for an entity component system, except the systems to operate on those components, because we haven't written the program yet. But before I even write that program, I'm not going down the road of an entity being able to be duplicated within our system. So each one of these objects needs another thing. The entity ID is great. That refers back to the originating entity, which it has inherited. It has inherited the original entity's ID plus all of its components. You can modify those components and then place it into a registry. Well, you can do what the hell you like with it, actually. We haven't got add to registry, have we? We can actually get objects now. We can reference entities. That's for the future. Don't worry about it. Let's worry about this practicality first, because this is the biggest one that they all miss. This is the one where they cock up and you get gold duplication at that point. And of course, well, we all know what happens from there, don't we? That's one dead game. So let's not go down the route of screwing it all up at the beginning and never ever considering the concept that people can duplicate, because we can duplicate, they can't. Well, of course they bloody well can. It'll just be hidden behind some keystroke somewhere in the middle of our system where we don't realise the connotations or implications of what we've just typed in. Because no one person can. These systems are too large. As you can see, an ECS system is massive. What are we actually talking about? We're talking about universal, unique identification numbers that each object that goes into your registry must have. There are plenty of things out there that will do this for you. Qt will, I hope. So we now have checked everything here. We haven't checked has component. Did we actually modify the table? No, we didn't. So we haven't got that. We do have this though. So that has now been tested. Let's go finish the component table before we go on to unique identification numbers. So, we inherit from there. Brain. What do you mean I haven't got a brain? Thank you. We inherit from an entity to make the basic object. We then register the object This is not to be confused with Qt objects. I'm not even going anywhere near that. Register the object into our scene. So far, so good. That means duplicate. To duplicate something, we can't. Need object UUID. Universal Unique Identification. If our object doesn't have this, think of this situation. You have a person firing a gun in a game. Every single bullet that leaves that gun is an object. Those bullets are all created from or inherited from an entity that is designed to be a bullet. The statistics for each individual bullet are set when it's fired, and those are used by the system to do its physics, trajectory and collision to detect whether it hits or not, or whatever. The bullet has a lifetime and is then deleted. How many objects have we got in the scene? Thousands! Yeah. Each one of those bullets needs to be unique with an identification, because when we come to delete it, which one do we delete? You can put a lifetime ticker on it and do auto delete and clean up at the end of your frame for that scene. That will take time. You can register each one as a unique UID and then just go through all of those UIDs that have been nulled. You just set it to a null. And anything with a unique ID of null gets wiped. A lot faster. You don't need a timer. You don't need to keep track. You can still have timers and keep track if you wish to, but that will be in the system, not the component. Do you get it? If your component has a timer, it is no longer recording just data. You could argue that time is data. It's not. Time is fictional. It doesn't exist. It's a thing that we express because we can't cope with the word now. It's not data. You can't use time as data. You can use it in a system to keep track of when an object should or should not exist, but you can't keep it within a component. The component is flat, factual, no messing about data. You shouldn't even have booleans within a component, to be quite honest with you, because they can just be true or false. Although that is the basic form of data for a computer, I'm not sure whether it's really a good idea either. People do. Hey ho, each their own. This also means that if somebody has a bag of crisps, goes up to another player and says, "Would you like a bag of crisps?" and they say, "Yeah," and you say, "Here you go," they can have it. You do not create a new object. You transfer that UUID from one player to the other. No new object is created. The same object still exists. The ownership has changed. Yeah. Are you getting the idea now that the UUID becomes more and more important on how you implement it? You should implement it from the start, not because it's a complicated idea, but because you want it within your systems. And you can't create your systems without the knowledge that objects are persistent. If a tree is standing in your world and somebody chops it down, the UUID does not change. The object may. It may get turned into planks. But it's still that tree. Its components have changed, not its ID. When you come to render the world, there's no tree there. There's a pile of planks. If somebody picks those planks up, those planks are no longer there. They're no longer rendered. Interesting. So why do you need this entity ID? Because you need to inherit. If you don't inherit, your system is going to be so goddamn slow, it's going to be untrue, because you'll be creating entities on the fly. Each bullet is an entity. Is it better to have that data and pass that data across and copy it, or is it better to sit there, go through a program of creating it? Okay, our program is very simplistic and very fast. We could get away with creating it on the fly. But as you see, we're going to add more and more components. Position isn't going to be enough. We're going to need model. We're going to need material. Get it? And each one of these has to have a UUID for the object, not the component. Although, to be fair, I am thinking of putting the UUID as the first item within each component. That does make for more memory usage. I've already broken all the rules of memory usage, so does it matter? It will do. When we actually come to writing this, remember this is just the design phase. We actually have to write this as a program. That's going to be fun. There are multiple formats of UUIDs. Why are they UUIDs and not just IDs? Because if somebody is sat in Australia and they fire a gun, the ID of their bullets can't match anybody else's. Otherwise, things can get awkward when you kill somebody. Whose bullet killed them? Yeah. So you can't have the person in England generating all the IDs. Can't have the person in Australia generating all the IDs. You could have the server generating a load of IDs, but that then means there is a time, there's some milliseconds there where an object doesn't actually have an ID. Is that good? Would you like to provide that ID, that UUID, instantly upon object creation? And I think that's the best place for it. How do you guarantee that they're unique? This is the great debate. This is the can of worms. We have some people saying that 64-bit is okay. Somebody generating a random 64-bit number will be fine. Yeah, probably will. Other people say that's too small. If you're going to go for an MMO, which is a massive multiplayer online, you're going to have to go for a 128-bit number because the size is just getting too big. And the number of items is getting too big. But that's not the truth of it. The truth of it is there's an easy way. You can stay with your 64-bit number. That's fine. But what you do is you split your UUID into different parts. So I go to settings. Device specification. We have this, a device ID. So we can actually take the device ID as the first part of your UUID and then tag a 64-bit number on the end that's random. Or we could do it the other way around. There's other things on here like the MAC address used for internet connections that describes your machine as a machine with an identity. Now they were running out of those. And they went from version 4, which was 4 numbers, to version 6, which was 6 numbers. So you could have more identities on the internet, and the internet could grow bigger. Nobody's bothered with that. They just stuck to the 4. Other things we could use? Don't know. Something unique. So something about the machine would be perfect. And that has brought us into the can of worms, UUIDs. There are UUIDs and there are GUUIDs. Universal. Unique. D. Global. So you could have a UUID within a system, and then you can have a UUID which is globally unique and universal outside of your system, which is the second one I was talking about, where you have to take some part of your system to identify where it originated from. What can we do about all of this? No idea. I can do a UUID quite simply. You just make a random number and shove it in there. Let's have a look. We have Bluetooth. Q, a UUID class stores a universally unique identifier. You just include it in core, and it's inherited by Bluetooth. Interesting. String format variant version. So we're using SHA, which means we're using hashed, because they can become pretty big. We do have a create UUID. We have versions. We have a CF, an NS, an RFC 4122. Can't remember what's in there, sorry. I've got the hash maps for them. So, this details it all for you. Numeric values as parameters, blah, 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 significant bits, X don't care, right, okay. So time is another one that they use. Network computing system. There's a Microsoft GUID. And it's usually on your computer. I'm on Linux. I'm hoping that we don't have one. Reserved for future expansion, love it. What else can we have here? So ID 128, like I said, 128-bit ones are universally accepted. So without braces, with braces. You can see how they're formatting it here to string. Variants. versions. This looks okay. My interface, yeah. And I made it a const, which is good, so nobody can alter it. Namespace, base data, basic data, RSC 4122. I might have to read it again. This is a big subject. You can see that they get big. They actually have a q-byte array because they are hashed. You can make your own. I'd have to look it up. This needs more research for which one we want. So as you can see, it hashes it. To make it secure. Right. This is a massive subject. What are we going to do about it? No idea. And that's why we need to stop now and think about it. It's a standard way to uniquely identify entities in a distributed computing environment. 16-byte, 128-bit number generated by some algorithm that is meant to guarantee that it will be unique and in the distributed computing environment where it is used. The acronym GUID is often used instead globally, but refers to the same thing. It doesn't actually, but anyway. The GUID is one variant, thank you. Multiple variants are in use. Each UUID contains a bit field that specifies which type variant of UUID it is. Call variant to discover which type of UUID an instance of QUID contains. It extracts the 3 most significant bits of the 8-byte. Yeah. In the QUID, byte 8. Yeah. If you create instance of QUID using the constructor that accepts all numeric values as parameters, use the following table to set 3 most significant bits of parameter B1. Right, so that's data 4, 0. That's bit mask. Contains a variant field in its 3 most significant bits in the table X means don't care. Network computing system, I think is probably, NCS is probably the one we're going to go for because that's the generic. But we need to know what that is. And is it going to be valid? Because I do intend to stick a server on this. Right, most platforms provide a tool for generating. UUID is generated by create UUID of a random type. That's not very good. Are set to DCE. The rest of UUID is composed of random numbers. Theoretically, this means there is a small chance that a UUID... Yeah, but it's very small. What's... This enum defines the values used in the version field of the UUID. The version field is meaningful only if the value in the variant field is... Right. Use time. Posit. A name. Alias for a name. Random and SHA-1. The simplicity. Distributed computing environment. That you know about these, don't you, from Microsoft, where they ask you to type in some kind of silly ID number for their CD for Windows. That kind of thing. Right, so we can... I want to know what that is. I think we're going to have to go for UUID, not QUUID. There's a good place to go. Oh god, it's in white. Why is Wiki still in white? Ah, this will have the standards on it though, won't it? But you can see how white I was employed as a researcher. It's not because I understand these things, which unfortunately I do. It's because I don't mind looking. So there's different versions of the time clock. Yeah. You can see that that's a Microsoft one because you can spot how it looks. And you've probably seen those kind of numbers before. Uniform Reese URN namespace. I don't think that's useful. Or a 48-bit timestamp. That's network computing system. So that's the one that uses a timestamp. The number of 4 microsecond units of time since the 1st of January 1980 UTC. Then we've got address family. Yeah. So the address family is literally an internet address. RSC 4122 DCE 1.1 UUIDs after the authors, yeah. Variant 2. Backward compatibility. Variants 1 and 2 are used by the current UUID specification. 1 sounds good. And swapping around other fields. Okay. Oh, variant 2 it says. Oh, God, no thanks. Right near that. 5 versions are defined for both 1 and 2 in the standards, and each version may be more appropriate than others. There we go. Date, time, and MAC address. That's what it is. So that's the one I'm after. Version 1. Which is the RSC 4122. In terms of binary representation of this QUID, the byte array is in, yeah, formatted according to, yeah, layout and byte order. Okay. Why does it say big endian format? Because on Linux, I think we're on little endian format, and on Microsoft we're on big endian format for internet protocols. Just means that things are reversed. Put it that way. Sort of. So how do we use this? Now I think I know what I would like. Example. Okay. That's it. No internet connection. You need an internet connection to be able to do these. Is that true? That could be a problem. Alright. I'm gonna try this, I think. How do we view them? I'm not so sure that this seeding method is good either. This isn't correct. That's not correct. That's the source code. Hmm. They're not exactly trying to be simplistic about this, are they? Well, that's how it's done. Yeah, that's what I'm thinking, how to match them. Let's check word wrap my positions, blah blah. This got to do with the state of fish. I have no idea why that's got anything to do with the UUID. Okay. I see. It all boils down to 2 lines at the bottom. That's an interesting idea. Hadn't thought of that. That's how to make it look representative, yeah. Alright, that's assigning a UUID to a widget. Name. Interesting idea. I wish to stop the adverts and getting annoyed with them. You can see now how in-depth people go with this stuff. Avatar UUID. What's this? Audio mixer client data. La 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 la. There we go. Read without copy. Yeah, that's... Okay. That one I like. They've actually done something that looks useful. Although I don't really want to do an audio mix client. Pass the UUID from the... Ah, they're doing it from there. Okay. There's some ideas there. we need to play with them. We can play with them in main. Main's a nice, gentle place that's not doing anything at the moment. Excuse me. Alright, so this is QUUID. How do we... let's play where? Let's just... we'll play at the top. Oh, for God's sake, stop it. I forgot this rule in this Qt creator. Easier. Okay. What can we do with this? First things first, how do we set it up so that we get something useful? They don't. Let's find out what the hell to do. All I'm going to do is UUID. I'm just going to find out exactly what's happening. We are going to throw this out as a string. Oh, so we can put two RFC41. Interesting. We'll try that in a second. String ST. Oh God, we're in Qt, aren't we? Dot to standard. There we go. Thank you. STD. Okay. No idea what that does. That's the whole point of programming. You're here to test things. You're not just a program. First of all, would that kind of thing build? Yeah, it'll build. And we do get a UUID. Now I find that interesting because how do I check what that is? So let's go back to the wiki. Okay. Where's my internet connection? Where's the information on it? Guys. Guys. That's not useful. You see, there's no MAC address here. Ah, here we go. Found you. Right, so we do have a MAC address here. And that is this number here. Okay. Two, 4, 6, 8, 10, 12. Alright, it's that bit. I don't know how it's hashed it. So you can't compare like that. Hmm. True. Equals something or other. How's about true? Bleh. Or even that. I don't know how much testing you people do when programming, but I would advise you do a lot. What do I want to do here? I want to test. Test is equal to for that UUID to D. Sounds stupid. Is it? Okay, let's try that little printout. Is it valid? Okay. Yeah. Valid. So we are allowed to program that way. Even though there's brackets on it, doesn't matter, we can still do an is equal to. Behind the scenes, Qt's doing it all for us. That's all we need. Is one line. It does everything we want. And with that knowledge, we can use it. Okay. Somewhere back in our scene. So it's not the entity, it's the object. We've discussed why. How did we get it to nil again? We have to set it to nil at the beginning. So we need to null it. Create. Warning, this function is only for Windows. No, it's not. Oh, that one is. There we go. Sets it to null. Is a constructor. Yeah, but that's what I want to do. Rather than a type in this context. I get you. What? Go away. Oh, it's because I've got an equal sign in there. Right, gotcha. Got to keep it statically the same. Sorry about that. It's a type def. But when we make an object, we have to define its UUID. And that will then, hopefully, right, I'll just use that one. And that'll do it. Alright, so back here, UI data. We can put this in now. No, just leave it like that. And it's going to be object. UUID. To string. To standard string. There we go. Save. Alright, let's have a look at the output. Yep, they're different. It works. So we now have UUIDs added to our objects, which is obviously pretty important for later on when we come around to using this kind of stuff. But we really, but we really need to think about it now. Even though it's a simple piece of testing and implementation that are placed into the program, what it means is the program has now got a way of defeating cheating. You can't cheat with this because only one object, you can't duplicate objects anymore. There's no way of doing it. Because each object now has a UUID. And if you try and duplicate one, it'll just get taken out of the game as a null UUID. It won't have one. I think it sets it to 0 automatically. And we need to check that, don't we? Really? Well, the answer is yes, we need to check that. So let's see if we can do that quickly. I'm all out of coffee and I'm running out of energy. So this is just going to be a quickie, I think. So we'll just dump it into scene. Just do a quick tester on this one. I don't want to leave this code in. Basically, all I want to do is check at this point here what it thinks the UUID is. Let's just print it to straight. Yeah. Let's see if we can crash the machine. Always good to crash the machine. Yeah, they'll both come out as zeros. Perfect. So it does set them to nulls, which means we can detect that. And by detecting it, we can remove the object. Because when you're detecting it, you will know what you're looking at. You can go through all of the objects and just wipe it out. We now have the perfect system for making objects which are unique, which do stem from an originating entity, and that we can wipe out at any time just by setting their UUID to 0 and then detecting that on a system cleanup. Perfect. That means you've just eliminated memory leaks. Yeah, I think systematically, for such a massive program of 1, 2, 3 functions, class scene and a type def object, which is a type just like int or float or whatever, we now have a way of constructing and systematically destroying these objects by removing them out of our registry once we find out that their UUID expires. How's about that? And that's what we've gained from all of this. And it wasn't complicated now, was it? There's no templates, there's no type T's going on here. Well, there are, but it's all hidden. And it's all very, very simple programming, and that's why it will work. At this point, you should only add to this class if you feel it warrants it, because your base class now is set. How many scenes can you have? As many as you want. You could be loading one scene whilst another one is still running. That in itself is an interesting thought, something that we might entertain at some point. So what it boils down to is, what have we actually done? We've created an ECS that's very, very simplistic, very solid, and complete. We can do what we want. At this point, I don't know if we can set... No, registry is static cast, blah, blah, blah. No, registry is not used in that line. Yeah, we can set that value. This is starting to look useful. I'm not changing the wording. So this is how we would use it. Wow. That's a pretty small instruction set for me. Am I happy with the way I've programmed it? Probably not. Will it do what I want it to? Yes. That's okay. How do you add components? Well, you don't do anything in here anymore, do you? Unless you want to add it as a base component, that is. You add a struct, and you add it to your components list. Job's a good one. Right. From this, can we start creating the first part of the game? Because we can create a player. So how do we create a player? I think we're done there. I am as happy with this as I can be. We've namespaced it. We do have choices. And we do have a scene. You can use this code, by the way, in any game. And that's the whole point of this code. I'm happy. Tools. Oh, we didn't do the list, did we? Still forgotten about it. As component. We do have to alter that. This comes under entity. So let's just take a quick look at that before I shut myself down. Where can we add that? Oh, mEntity has component entity ID, blah, 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 equals 1. Yeah, we have done it. 1 is true, so we can detect it on true. We can put has component in brackets and use if statement. Eat ifs. I hate. You might notice a lack of them. Every time I write an if statement, by the way, I normally delete the code. I haven't written any in here. Please tell me. We've left this in. Remove. Quickly, before I forget. If I don't remove stuff, then I do forget. Okay. King of Cane. Perfect. Alright, I'm happy with the code. We haven't checked the systems angle. which is where you use that lookup table. Scene, objects, inherit, entity, constructed with a position component and given d. Note. Component lookup table not tested as no system yet exists. Done. There's our program. Not very graphical yet, is it? But we can now construct a player with a position. We can construct a player with whatever the hell we like, really. But we do have to expand on that, as we're going to find out. Right. That's the initial code for the project. We have completed step 1, what I would call the necessary steps to create the first foundation stone of a game. What this means is we can now start making the game more visual, as this is going to be very, very easy to do. We're going to choose a very, very simple style of graphics probably initially. Probably end up 3D, knowing me. But initially that's not where you want to go. Not with a game. You want to have baby steps, as you just found out. We went from nothing to something rather huge. Most games screw that bit up. Right. I'm happy. Are you happy? Any questions? Anybody want to know anything? Does anybody want me to? It's the same code on Windows, Mac. There's no difference. It's all there. Who did that wrong? No, I didn't do it. Thought not. So like I said, I'm not a programmer, I'm a systems analyst. I know what the mistakes are. And I hope that was an interesting enough... Oh, did you notice how it shut down properly? Yes, I've been redoing my system. So I'm hoping that gives you a good introduction on probably where to start with a game. Even if you're doing Pong, we can now make player 1 a bat, player 2 bat, and a ball. You can make any game you like. Platformers to 3D to whatever you would like. Okay. Any questions now? Anybody want to specify a game? I hadn't even decided what the game is. I just decided I wanted to make one. Do we make something where an arena, combat arena, something like that? Something pretty simple that can become pretty complex? We can design physics, we can do player progression, items, equipment, a shop. Do anything. Now we have the basic construct, we can do anything. We can create any scene we like. I want to do physics. Now, nothing next will get a visual screen up. Something we can interact with. We'll do interaction. Good. Yeah, we'll keep that. That was good. And as there's no questions today, I hope people might see this. This is going up on YouTube as the introduction to the game club. I would like to remind people that this is not for me to experiment in making games. This is for you to ask questions, want me to look at different languages if need be. I am a researcher and a systems designer. I'm quite happy to do anything that people want to do. And in the meantime, if there's no questions or whatever, I'll just accidentally make a little game. Big thanks, peeps. And a big thanks, Polly. That's the intro over. I'm going to go and feed the cat. How do we stop streaming? Oh, it's here. Found it. Found the button. Take care. And enjoy yourselves. I'm going to come back tomorrow and we'll probably try and do some kind of visualization. I'm happy with the ECS. Take care. Have fun.